So we are talking about solving by square rooting. And this comes after we talk about complex numbers. So we're going to watch out for I. But we're going to solve by square rooting whenever we have, oh no, that's fun. All right. Whenever we have either x squared equals something or something in parentheses with x, that thing squared equals something. Okay, so I'm going to start by trying to get my x squared alone. And remember, you're going to use, please excuse my dear Aunt Sally, you always do parentheses first, but then you undo things backwards when you're solving. So I have to undo addition and subtraction first. So I'm going to add 7. And that gives me 3x squared equals negative 48. And then I need to undo multiplication by dividing by 3. And that gives me x squared equals negative 16. So now I can undo exponent by taking the square root. And I always need to make sure that when I take a square root, I do a plus or minus on the right side, because when it is a degree 2 equation, I am going to get 2 answers. So the square root of x squared is just x, and then the plus or minus, that's a negative 16. Remember, we learned about I, so we said when you have a square root of a negative, you're going to turn it into square root of negative 1, which is I, times the square root of 16, which in this case is a perfect square, so it's 4. I'm always going to write the plus or minus, and then I will write the number before the I. The square root will go last if it's not a perfect square, which we will see on the next one. So these are just some problems that I've chosen from the notes. Okay, for the next one, we have this pesky fraction. So the way we're going to get rid of a fraction is multiplying by the denominator on both sides. So then I'll have x minus 4 quantity squared equals 33. Now the thing that is squared is alone, so now I can undo that by taking the square root, and whatever I do on the right side, I'm going to do a plus or minus. So then I have x minus 4 quantity squared, and then 33. Square root of something squared is we're just going to get x minus 4. And then we have plus or minus square root of 33. Now to get x alone, I'm going to add 4. And so when I add 4, I'm going to put it in front so that I have x equals 4 plus or minus square root of 33. Since 33 is not a perfect square, I'm not going to do anything else with it. I will just leave it just like that. Okay, then for this one, I have another fraction. I can get rid of the fraction by either multiplying by the denominator, like I did with number 7, or multiplying by the reciprocal. So if I multiply by just the denominator, then those cross out to 1, and I'm left with 2 outside of the x plus 3 quantity squared, and 50 on the right side. This is, again, multiplication, so I'm going to divide to get my squared term alone. I could have also just multiplied by 5 over 2 to get rid of the whole fraction all at once. And then that gives me x plus 3 quantity squared equals 25. I'm going to take the square root of both sides with a plus or minus. So I get x plus 3 from the left equals plus or minus 5, because 25 is a perfect square. Then I can subtract 3 from both sides, but again, I'm going to put it in the front. So I have x equals negative 3 plus or minus 5. So this means x could equal negative 3 plus 5, or x could equal negative 3 minus 5. So negative 3 plus 5 is 2, and negative 3 minus 5 is negative 8. So again, I got 2 answers for this one. And then the last one that I want to do is number 12. see if I can get it done before the big husky announcement. Okay, so I'm gonna get this x, whatever's being squared alone, get negative 12. And when I take the square root, I'm gonna do plus or minus square root. So I have x minus 2, and I have a negative 12. Sorry, squared. So x minus 2 equals plus or minus I square root of 12. Because square root of negative 12, I'm going to split into square root of negative 1 times square root of 12, and that becomes an I. And then I want to add 2 to both sides. So then my final answer will look like,
May I have your attention, please? All students remaining in the building must be under the